Okay, so let's take a look at another example before we jump to another type of parabola. Okay, so example number 6. So I have an equation like this: x squared minus 4x equal 8y minus 28. Okay, and the question is, determine the vertex, focus, and the directrix. Okay, determine vertex, focus, and directrix. Okay, answer. In order to determine the vertex, focus, and directrix, we need to bring it back to the form, right? And so far we already learned two forms: the one with origin, the one with vertex at the origin, and the one with vertex is not at the origin. Okay. By looking at the equation right over here, we probably know that the vertex of this parabola is not at the origin, because if this is at the origin, it looks very simple. Over here, this doesn't look simple at all. That's why the vertex is not at the origin, and that's why we have to complete the square to bring it back to the form. So we have to complete the square to bring it back to this form right here. Okay, so we need to have a perfect square on the x. Okay, all right. So we don't know that it could be plus or minus. After we bring it back to this form, then we know a plus or minus. Then we know this is going to be opening up or opening down. Because I already said, I don't know if you guys remember, I said that if it is positive, then we know it's opening up. If it is negative, then we know it's opening down. Okay. Oh, let me. Okay. Alright. So we try to get it to a perfect square for the x. So I'm gonna bring all the term with x onto the left hand side. Actually, it's on the left hand side already. And on the right hand side, we have 8y minus 28. So you see that this is negative 4. So in order to complete the square, I'm gonna take this divided by 2 and I square it. This will give you 4, right? Give you 4, and that step you already learned in college algebra. So it means that you have to add 4 on this side also. Okay, so I added 4 on both sides of the equation. Then I will get a perfect square right here. Okay, on the right hand side I will have 8y minus 24. Alright, and I'm gonna factor negative. I'm gonna factor the 8 out, so I will have 8y minus 3. Okay, so look like that this is opening up because this is positive. So I can rewrite it as 4 p y minus k, right? And over here x minus h, right? Okay, then I can get the vertex is 2 and 3. Okay, the focus is right here. The focus is right here. Sorry. So the focus will be f. because this is opening up. Okay, it's opening up, and the origin, the vertex is not at the origin, so we have to be careful with when writing the coordinate of the focus. Be careful. So just imagine, so this is 2 and 3. So the vertex is 2 and 3. It means what? It means that so let's grab it quick right over here, then you know right away. So right here, we know that the focus, the vertex is 2 and 3, so 2 right here and 3 right here. So this is the vertex like this. Is opening up, and we know as P is 2. We know P is 2. It means that P is 2. It means what? So P is 2. It means that the distance between the focus and the vertex is 2. Okay. So it means the F must be right over here. Okay, the F must be over here. Okay, if you guys write the coordinate of F is 0 and 2, then you got them wrong right away. Okay, because this the vertex is not 0 and 0 anymore. Okay, so over here we just know the distance between the vertex and F is 2. Okay, it means what? It means that I can write the coordinate of the focus will be 2 and what? 1, 2, 3, 4, 5. 2, 5. Okay. The focus will be 2, 5. Okay, so be careful. All right, and the directrix will be what? The directrix will be down over here, because the distance between the vertex and the focus is the same as the distance between the vertex and the directrix. So the directrix is right here. The directrix is right here. It means that the directrix will have equation y equal 1. Okay, there we go. Directrix. Okay. So when you guys dealing with parabola, which vertex is not at the origin, you have to be careful. Okay, you have to go ahead and sketch it, and so that you know right away. You know right away the coordinate of the focus. Don't memorize the formula, because some of you memorize the formula, and some instructor might recommend you to memorize the formula, but I never recommend a student to memorize it. You need to understand what the graph look like, then you know right away the coordinate of the focus and where will be the directrix. Okay, so that is the last example for vertical parabola. So far we've been talking about a vertical parabola only. Now I want to talk about horizontal parabola. The difference between the horizontal parabola and vertical parabola is that you just need to switch between x and y. In vertical parabola, we know variable x. We know that variable x has the highest power, has the second power. But for the horizontal parabola, we have variable y with the highest second power. Okay, so you will have y squared instead of x squared. Then the general formula for the horizontal parabola will be y squared equal plus minus 4px. Okay, so we have, if it is positive, you know that it's going to be open to the right, and if it is negative, it will be open to the left, and everything will be the same. Everything will be the same. So let's sketch a quick horizontal parabola, something like this, because this one is the one with vertex at the origin, so we can have something like this. Okay, so the F must be around here. We don't know where, but the F must be on the x-axis. It means what? It means that the focus of F, the coordinate of the focus F will be what? Will be plus or minus P0. Okay, I'm gonna box this formula, the equation. Okay, alright, and the directrix will be around here. So instead of writing y equal, and this will be x equal, so x will be equal to plus or minus p. Okay, so that is the directrix. Okay, and of course we will have a lattice rectum also. The lattice rectum will be over here and over here. All right, and if we pick any point, you see, because my parabola again is not scale, so if you pick any point on the parabola and you connect it to the focus and you draw perpendicular to the directrix, it should be congruent. Okay, because you see that my parabola is not scale, so it doesn't look like congruent, but it must be. So the eccentricity, the E, must be 1. Okay, but this is for horizontal parabola. I'm gonna put over here horizontal parabola. Okay, similarly, if we have parabola, horizontal parabola, which vertex is not at the origin, we will have something like this. We will have y minus k square. Okay, y minus k square equal plus minus 4p x minus h. Okay, so the vertex over here will be what? The vertex over here will be again with still h and k. Okay, and because the vertex is not the origin, so it's good if we go ahead sketch them and we can get the coordinate of the focus. Okay, don't ever use the formula. Don't ever use the formula without understand anything. Okay, the eccentricity is still 1. Okay, so this is the second formula for horizontal parabola. Okay, I'm gonna do the example, then you guys know right away what it looked like. Okay, how about this? Okay, so example number, so this is number 6 already, right? So example number 7. Example number 7. So I'm gonna have something like this. I will have something like x equal negative 2y squared plus 4y minus 3. So you know, by reading this, you know right away that this is a horizontal parabola, because the y variable is the one with the second power, not the x. Okay, then this one must be horizontal parabola. Okay, and we know right away that this is the one which origin is which vertex is not at the origin. Okay, I mean the vertex could be somewhere else. It's not at the origin, so we have to do completing the square in order to bring it back to this form. Okay, to bring it back to this form. So how are we gonna do that? Okay, all right. So I'm gonna add 3 both sides. So I'm gonna have this. Okay, so I try to complete the square right here. Then I'm gonna factor -2 out, and we have y square minus 2y. Okay. And you see the y square minus 2y, I take the middle term is 2y divided by 2, and you square it. You remember the step we are learning college algebra. So divided by 2 and I squared it, so we have 1, right? Then you have to subtract 1, because you cannot just go ahead add 1, but you have to subtract by 1 in order to cancel them out. Okay, you see that this is cancelled out and it give you this, so this is the same as this. All right, then I distribute the -2 in. -2 times -1 give you 2. Okay, give you 2, and this is the perfect square right here. Okay, I'm gonna subtract both sides by 2, so I have x plus 1 equal -2y minus 1 square. Okay, and then I divide both sides by -2, so you have y minus 1 square equal to -2 x plus 1. Okay, so it's almost in the form, right? So it looks like that your k is 1 and your h is -1. Okay, but we need to bring it to the 4, and we know this must be the this parabola is open to the left, so it's gonna be, let's rewrite it with the number 4. So we have -4 times 1/8 x plus 1. Okay, alright, so from here I can get the vertex. So the vertex will be -1 and 1, right? -1 and 1. Then we can sketch it so that we can write the coordinate for the focus and the directrix. So we know this is going to open to the left, so it must be something like this. So -1 and 1 is, so -1 and 1, -1 and 1 is right here. So that's the vertex, and it's gonna opening to the left like that. Okay, I'm just sketching. Okay, we don't have to be perfect. So that's -1 and 1, and we know that 1/8 is kind of very small. You know, 1/8 is kind of super small. Yeah, it's very small right here. So the p is 1/8. So the distance between the vertex and F is just 1/8. So this is your F right here. So from here to here is 1/8. Okay, then I can get the coordinate of F will be what? Will be the x component will be -1, -1 and -1/8. All right, -1 and -1/8, and the y component will be 1. Okay, then my F will be -9/8 and 1. Okay, so that is the coordinate of the focus. All right, and because this is 1/8, so this 1/8 over here, so the directrix must be between the vertex and the y-axis, because it's just 1/8 right here. So from here to here is 1, from here to here is 1, and from the vertex to the vertex is from the vertex to the directrix is 1/8. So the equation will be x equal 1 minus 1/8. So the equation will be negative. Okay, I'm sorry. The equation, because this is 1 from here to here is 1/8. So the equation will be negative 7/8. Okay, the equation will be negative 7/8. Okay, because it's not sketch, because it's not graphed perfectly. It's just a sketch. So it's just I'm gonna just go ahead and draw over here, so that I try to sketch it so that you guys can see. So I have parabola like this, right? And over here is 1/1, so it's something like this. So it's 1/8 is from here to here. So f is right here. It's really small. So the directrix is right here. So this is from here to here, from here to here, and from here to here is 1/8. From here to here is 1/8. From here to here 1/8. So the directrix equation must be from here to here. So that you take 1 minus 1/8. So give you 7/8 as the distance. But because we want to write the equation of vertical line of the directrix, so it must be negative 7/8. Okay, so negative 7/8 right here, right here. Okay, so that's what it is. All right. Let's see. We can do another one. Let's do another one. I mean, you guys should be you guys should know how to complete the square. You see, completing the square is very important, right? Without completing the square, that you guys don't know how to get the equation. Okay, let's see. It's not hard. It's not hard at all, as long as you really understand it. Very easy, guys. Don't worry. Very easy. All right. Let me see. I mean, I have I try giving you kind of a challenging problem, but all the problem is very standard, you know. It's just something like this. I mean, it's nothing hard. Yeah, I mean, so easy. Everything is so easy, you know. Let's try to do this one. I mean, this is easy too, but I mean, I couldn't find something harder, so I mean, I want you to write equation of parabola, okay, which has focus F is 1, 2, and directrix y equal 4. Let me see. I think I'm going to change it later, but so with directrix x equal -1, and this one I'm going to change this is 2, 1, 2, 1. Okay. Alright, so how we do that? Okay, so directrix, the f is 2, 1, directrix is x equal -1, so you know that it's going to be open left or right, right? X equal to -1, so something like this. So -1 right here, so this is directrix already. Okay, we know f is 2, 1, so 2, 1, so 2 right here and 1, so f is right over here, right? And you know that the vertex is always between the directrix and the focus. It means what? It means that the vertex must be somewhere right here. Okay, so this is a focus, so this is directrix, so it must be opening to the right, and the axis of symmetries must be over here, right? So the vertex must be right here. Okay, it must be right there. All right. But how? What is the coordinate of the vertex? We need to find it. Okay, easy, very easy. So the directrix x equal to -1. It means we need to find p, right? We need to find p. We need to find p. We need to find the coordinate of the vertex. It's very easy because over here is f, right here is 2, 1 already. So f is 2, 1, right? And it's 2, so it's 2, 1. And over here is the coordinate right here is -1 and 1, right? This is -1 and 1 right here, right? That point right here, -1 and 1, right? So we can find the midpoint, and we can find the midpoint, the coordinate of the midpoint easily. Okay, so and the midpoint is the vertex. The midpoint is the vertex. Okay, so we know the midpoint, which is the x of v, will be 2. This plus this will be 2 plus -1 over 2. So it will be 1 over 2, right? And yv will be 1 plus 1 over 2 will be 2 over 2. Will be 1. So the coordinate of the vertex will be 1 over 2 and 1. Okay, so on the test you have to show me this. You know, if you graph it carefully, actually you can take a guess. You can guess this, the coordinate over here is 1, half and 1 right here, but I want to see the work. So I can draw the coordinate of the vertex. Then my equation will be what? Will be y minus 1 square, right, equal to 4p x minus 1/2. Right? Our job is what? Our job is to find p. Our job is to find p. So what is p? P is the distance between the vertex and f, which is in this case, I can find the distance between the vertex and f by using the distance formula, right? So I can find p. Okay, using the distance formula, will be xf minus xv. So it will be 2 minus half square plus yf minus yv, so square 0. So this is give you 3/2 square, so just 3/2, right? Yes. Then I can get p is 3/2. Then my equation will become y minus 1 square, 4 times p 3/2, x minus 1/2. Then it gives you 6 x minus 1/2, y minus 1 square. Okay, then you have the final answer. Very easy. Okay. I mean, you can get the p by reading the graph, but it's good if you show me the work. You have to show the work. Okay, don't just read the graph. Okay, don't just read the graph. All right. Okay, so I think we're gonna stop the lecture today. You see that this lecture divided into 3 parts, kind of very long one, but it looked like that we already finished section 8.1. In the next video, I will be talking about another conic curve, section 8.2. I will be talking about ellipse and hyperbola. Okay, see you next time. Bye bye.